Hello everyone, my name is Marina Margarian, and in this video I will be discussing an article based on a study facilitated by Larry A. Tucker evaluating caffeine consumption and telomere length in men and women of the National Health and Nutrition Examination Survey. The following is a list of facilities involved. All data used in the study were provided by the U.S. Centers for Disease Control and Prevention as part of the National Health and Nutrition Examination Survey, which I will refer to as NHANES in this discussion. The Ethics Review Board at the National Center for Health Statistics was responsible in approving the collected NHANES data, making public posts, and providing written informed consent to participants of the study. DNA samples were extracted and stored at the Division of Health Sciences Laboratory at the CDC and then shipped to the University of California, San Francisco for analysis. And lastly, the College of Life Sciences at Brigham Young University in Utah provided Larry A. Tucker, the author, a location where he could design the experiment, organize and analyze the data, as well as write the manuscript. The purpose of this cross-sectional study, or essentially an observational study, was to investigate the relationship between caffeine intake and coffee consumption and leukocyte telomere length. Caffeine is everywhere, found in many conventional products from popular beverages and nutrition products to pharmaceutical drugs. Coupling the availability of caffeine with its physical, metabolic, and psychoactive influence on the human body, it shouldn't be surprising to see why the topic is of particular interest. Former studies have focused on the relationship between coffee and disease and mortality, but research on caffeine and telomere length is rare. For example, the health professionals' follow-up data along with the nurses' health study data found that coffee consumption was inversely related to all-cause mortality, mostly because of a moderately reduced risk of cardiovascular disease. However, because decaf coffee was also associated with the same risk reduction, this suggests that something other than caffeine was a contributing factor. Similarly, Lotfield et al. Found that as coffee consumption increased, all-cause mortality decreased. But once again, decaffeinated coffee was analogous. And finally, a study by Liu et al. Illustrated that higher coffee consumption in female nurses were related to longer telomeres. However, after adjusting for confounding variables, the predictive nature of caffeine on telomere length didn't seem as strong. Additionally, the study was less specific to caffeine and focused predominantly on coffee. You're probably wondering what exactly a telomere is and what its length has to do with cellular senescence. Let's take a closer look. At the ends of each chromosome are these nucleoprotein structures which protect the chromosome from fraying and getting damaged. As seen in the photo to your left, these nucleoprotein structures are made of a simple DNA sequence, TTAGGG. Every time our chromosomes replicate, these telomeres become shorter and shorter. And our telomeres naturally replicate and shorten with age. However, they can also shorten as a result of stress, smoking, obesity, lack of diet, a poor diet, etc. It shouldn't be surprising by now how crucial maintaining their length is to our overall cellular senescence. Because the present study was observational in nature, the majority of its methods focused on the dissemination and organization of data already in the NHANES in an effort to answer the research question. Therefore, it would probably prove useful to give you a short introduction on the NHANES. The National Health and Nutrition Examination Survey, which is conducted by the Centers for Disease Control and Prevention, is a compilation of data that has been gathered for over 50 years and provides information on the health and nutritional status of non-incarcerated individuals in the United States. As a starting place, the present study requested DNA samples from respondents of the 1999 through 2000 and 2001 through 2002 NHANES. Those selected to move forward in the study included adults ages 20 and older who were eligible to submit DNA samples and had previously consented to future use of their DNA. All others, as well as individuals older than 85 years of age, were excluded. The final sample consisted of 5,826 participants, among whom 2,741 were men and 3,085 were women. Next, data were collected on 13 variables, which were leukocyte telomere length, caffeine intake, age, gender, race, education, marital status, housing, body mass index, smoking, physical activity, alcohol use, and coffee intake. To measure leukocyte telomere length, a quantitative polymerase chain reaction method was used. Dietary intake were collected via a 24-hour dietary recall. A 24-hour diet recall is an interview to collect any and all food and beverages consumed by a respondent in the past 24 hours. Interviewers were bilingual, trained, and had a college degree in either food and nutrition or home economics. To maintain a standardized interview format, interviewers were provided with scripts. The collected data were then used to calculate the caffeine intake and coffee consumption for each respondent. To determine whether certain statistics affected different groups or populations, the NHANES made use of different categories, otherwise known as covariates. These included race and ethnicities, several lifestyle factors, smoking, body mass index, and alcohol use. And to ensure that the sample size would be an accurate representation of the population and unbiased at best, the NHANES assigns an individual level sample weight to each participant. This is known as unequal probability of selection and is comparable to random sampling. Now that we have a better understanding of the incorporated methodology, let's get to the meat and potatoes of the present study. Some general characteristics of the sample size. Mean age of sample was 46.9 plus minus 0.5 years. Mean caffeine intake from foods and beverages was 195 plus minus 9 milligrams per day. Mean coffee intake for the sample was 342 plus minus 21 grams per day. And mean telomere length was 5,828 plus minus 40 base pairs. Table 1 to your right shows the weighted percentile indicated by the plus minus SE logo for telomere length in base pairs and caffeine consumption in milligrams per day. You'll notice that as the amount of caffeine consumption increases, so does telomere length. Table 2 shows the relationship between caffeine intake and telomere length, and between coffee intake and telomere length. After adjusting for covariates, caffeine was inversely related to telomere length. If we focus on the top half of the table, we'll see that among all participants for each 100 milligrams of caffeine consumed per day, telomere length was 35.4 base pairs shorter. When limited to only coffee drinkers, telomere length was 36.7 base pairs shorter. And in adults who reported no coffee intake, telomere length was 40 base pairs shorter. Now reverting our eyes to the bottom half of table 2. For each 100 grams of coffee consumed, telomeres were on average 15 base pairs longer. And when limited to only coffee drinkers, telomeres were 17.9 base pairs longer. It's safe to say that coffee consumption, at least in terms of this study, was positively related to the length of telomeres. Furthermore, the age-related rate of telomere shortening was 15.3 base pairs per year, with a biological age difference of about 2.3 years for every 100 milligram caffeine consumed. Among coffee drinkers only, the difference was 2.4 years, and among no coffee intake, the difference was 2.6 years, which circles back to the idea of cellular senescence, or for the less fancy, cellular aging. Brace yourselves for this one. Cellular aging among coffee drinkers was a whopping 2.6 years less for each cup of coffee consumed relative to only 2.2 years less among US adults. If coffee can help slow down the clock, then who am I to complain? In fact, allow me to pour a cup before we proceed. It goes without saying that more research is warranted, as the study is among the first to evaluate the relationship between caffeine consumption and telomere length. This would be particularly invaluable for certain covariates such as obesity and smoking. However, to better apply a directional path for future research, it would be useful to understand the limitations of the present study. Primarily, the study was cross-sectional and did not warrant a cause and effect type assessment. The inverse relationship between caffeine intake and telomere length could have very well been reversed. It's possible that shorter telomeres could lead to more caffeine intake. Moreover, there could have been an unaccounted for third variable. Additionally, the present study did not identify diseases or controlled for them. Therefore, cellular aging could have to do with factors other than caffeine consumption. Although both the NHANES and the present study's experimental design had put forth several methods to prevent the potential of bias within their sample size, the majority of information came from respondents' self-reports. Any future research must be geared towards minimizing these limitations in their application of the experimental design to strengthen findings. For those of you interested, These are the references used in my presentation and analysis of the present study. If you've tuned in this far, thanks for listening. Hopefully, the information contained within this study has been beneficial and will allow you to make better lifestyle choices for your individual health. Should you want more information on the topic or have ideas on future research, don't hesitate to reach out to Larry.